Hello, today we're going to look at dividing radical expressions. Before we get to dividing, one quick concept that we all need to make sure we know is what happens when a radical gets multiplied by itself. If you take a look at the three questions up at the top of the notes, let's look at what happens when we multiply the square root of 3 times the square root of 3. We know that when we multiply radicals, we multiply the numbers underneath of the radical sign. So 3 times 3 makes a square root of 9. But 9 is one of our perfect square numbers. The square root of 9 is 3. When we multiply the square root of 8 times the square root of 8, we get the square root of 64. But again, 64 is a perfect square number. Its square root is 8. When we multiply square root 11 times square root 11, we get the square root of 121. Again, 121 is a perfect square number. Its square root is 11. So I'm sure you notice when I multiply a radical by itself, we just get the radicand. Square root 3 times square root 3 is a plain old 3. Square root 8 times square root 8 is a plain old 8. If I multiplied the square root of 76 times the square root of 76, I know I'm going to end up with just a plain old 76. We're going to use this idea when we divide radicals because when we divide radicals, we cannot leave a square root in the bottom of a fraction. And of course, fractions are the same as dividing. So we have to do something that's called rationalize. To rationalize the denominator means that we get rid of the radical from the bottom of a fraction. And we're going to use the idea that to get rid of a radical, we can always multiply by the exact same square root to make that square root disappear. So when we simplify fractions, simplify radicals that have a square root in the bottom, we're going to multiply both the top and the bottom of the fraction by the square root that we want to get rid of. To rationalize the denominator, we're going to multiply top and bottom of the fraction by the square root that we need to get rid of. So take a look at question number 1. In question number 1, we have the square root of 3 over 10. So the first thing I'm going to do is split this up into the square root of 3 over the square root of 10. Now I'm not allowed to have the square root 10 in the bottom of the fraction, so I'm going to multiply that square root 10 by another square root 10. And I know that when I do that, I get a plain old 10. But whatever I do to the bottom of the fraction, I also have to do to the top of the fraction. So I'm also going to multiply the numerator by square root 10. And when I multiply square root 3 by square root 10 in the top, I get the square root of 30. So we've rationalized the denominator. We've gotten rid of the square root in the bottom of the fraction. We always have to make sure that there's nothing else to simplify. In this case, there's not. There are a couple of things that we look for. We need to make sure that there are no perfect square numbers that go into our radicals, and there is no perfect square number that divides into 30. And then we also have to make sure that we can't reduce the fraction because the 30 is underneath of the radical sign and 10 is not. We cannot reduce those things. Remember, outside numbers stay with outside numbers, inside numbers under the radical stay with inside numbers, but we can't combine them together. So this is our final answer. Okay, in question number 2, we have square root 6 in the bottom of a fraction, so we have to rationalize to get rid of it. To get rid of the square root of 6, we're going to multiply both top and bottom of the fraction by square root 6. In the top of the fraction, a plain old 4 times the square root of 6 is 4 root 6. And in the denominator, square root 6 times square root 6 is a plain old 6. Here we can simplify. If I look at the radical first, square root of 6, the radical is already simplified. There is no perfect square that goes into 6. However, if I look at the plain old numbers outside of a radical, 4 over 6 can be reduced. They're each divisible by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And then the square root 6 stays as it is. So my final answer here, 2 root 6 over 3. In question number 3, let's start again by breaking up and making two separate radicals, one for the numerator, one for the denominator. So here I have the square root of 12 over the square root of b squared. In this question, I do have perfect squares that go into the radicals, so I'm going to simplify each radical by itself first. So if I just look at the square root of 12, I know that 4 goes into 12, so I can split this into the square root of 4 times the square root of 3. But the square root of 4 is 2, and the square root of 3 stays as it is. In the denominator, b squared is a perfect square. Remember, we divide the exponent by 2 when we square root a variable. And here, 2 divided by 2 is 1. So the square root of b squared is just b to the first power, or a plain old b. In this question, once we've simplified each of the radicals, we actually have our final answer. There is no square root left in the denominator, so we don't have to rationalize. This is one of the lucky cases where the denominator is a perfect square. So if I just take its square root, I don't have to go through the process of rationalizing. Okay, in question number 4, we have 3 root 2 over square root 5. We can't have a radical in the bottom of the fraction, so we're going to have to start by getting rid of that square root 5. In order to do that, we're going to multiply both top and bottom of the fraction by square root 5, by the radical that we want to get rid of. In the numerator, when I multiply 3 root 2 times square root 5, the 3 on the outside stays the same, but underneath of the radicals, 2 times 5 makes square root 10. In the denominator, square root 5 times square root 5 gives us just a plain old 5. Then we have to look at the square root. There is no perfect square that goes into 10, so that can stay as it is. We also check our plain old numbers to see if we can reduce, but 3 and 5 do not have a common factor, so this is our final answer. In question number 5, let's start again by making two separate square roots, one for the top and one for the bottom of the fraction. So I'm going to rewrite this as the square root of q over the square root of 12. I notice that there is a perfect square number that goes into 12, so I'm going to simplify the bottom before we rationalize. So square root 12 can be broken into the square root of 4 times the square root of 3, but the square root of 4 is 2, so this can become 2 root 3. In the numerator, q is not a perfect square, so that's going to stay just as the square root of q. Okay, when I look at what I have once I simplify the denominator, and I'm just going to rewrite it, when I look at this denominator, I can't have that square root 3. So to get rid of the square root of 3, we know to rationalize. So we're going to multiply the top and the bottom of the fraction by the square root of 3, just like we did before. Multiply by the radical that you have to get rid of. In the numerator, underneath of the radical sign, we end up with 3q. In the denominator, when I multiply the square root of 3 times the square root of 3, I get a plain old 3. And when that plain old 3 pops out, it gets multiplied by the 2 that was already there. So in the denominator, 2 times 3 makes 6. Underneath of the square root sign, there is no perfect square that goes into 3, so the radical is simplified. We cannot reduce anything top to bottom because the 3 is underneath of the radical sign, but a 6 is not. So this is our final answer. And now in the last question, number 6, we have the square root of 6 over 7 times the square root of 1 over 3. Let's multiply these two radicals first. When we multiply fractions, we know we multiply their numerators. So 6 times 1 is 6. And then we multiply their denominators. 7 times 3 is 21. Underneath of the square root sign, let's reduce the fraction. It's always easiest to work with smaller numbers. So 6 over 21, each of those numbers is divisible by 3. So let's divide 6 by 3 is 2, and 21 divided by 3 is 7. Now I'm going to break up one radical for the numerator and one for the denominator. I'm not allowed to have that square root 7 in the bottom, so I multiply both top and bottom by square root 7. In the numerator, 2 times 7 makes this the square root of 14. In the denominator, square root 7 times square root 7 makes a plain old 7. Always check to see if you can reduce. There is no perfect square that goes into 14, so the radical is already simplified. And we cannot reduce top to bottom because the 14 is underneath of the radical, but the 7 is not. So this is our final answer. Now that you've completed the notes, please work on the homework, which is on the next piece of paper. Make sure you show your work for full credit. If you have questions, please post them under the comment section of Teams. Have a great day.